Hello everyone. Today's video is not a typical APB tutorial you see on YouTube. This is a complete end-to-end APB implementation that you can directly use in your verification project. So in this single video, we will cover complete APB theory, your RTL design implementation, as well as the full test bench development with detailed explanation of your each logic. So I have also added some proper timestamp, so if you already know the basics, so you can jump directly into the test bench section. And here's the exciting part. If this video get a 20 comments, then in the next videos, we will going to cover a full APB VIP with multiple agents step by step. So comment your favorite part of the video and let me know what you want next. Alright, enough talking. So let's jump straight into the video. And if you want a mock interview from our side, so this is our mail ID. So you can just mail us on this mail ID. We will definitely conduct your mock interview and give you a valuable feedback. Okay, so let's jump into this video. So see, before starting this, these are the agenda for our today's session. We are going to see why APB. We are going to see what's the basic included in APB protocol. Then we will see the operating state which was there in your APB protocol. And then finally we will jump into the transfer, how your transfer actually happening in your APB protocol. Okay, sounds interesting, na? Okay, so let's jump. Okay, so here you can see the introduction to AMBA APB protocol. Before starting any protocol, first of all, you have to know what's the mean by protocol or what's the meaning of protocol. So see, what's the meaning of protocol? So if you want to establish some communication, so in that case, you need to follow some set of rule. So that set of rule is nothing but your protocol or communication protocol. I hope it is clear to all of you. Okay, so suppose this is my person 1 and this is my person 2, and my person 1 want to talk with this person 2. So if he want to talk with person 2, so he needs to follow some rule. So that rule is nothing but your protocol, and in terms of electronics, we are calling it as an communication protocol. Okay. So see, APB stands for Advanced Peripheral Bus, and it's a part of your AMBA family which was developed by ARM. So it is designed to connect a low bandwidth peripherals like your timers, UART and GPIOs. So what does it mean by the peripherals? So peripherals may be your memory, maybe your timers. So all of these are like an peripheral to which you are establishing a communication. Okay. So APB is known for its simplicity and low power consumption. So except like the other protocols which we have in your AMBA family like AXI and HB, as compared to that, your APB is a simpler one and it also consumes a low power. So which makes it ideal for any control register access in peripheral. Now the transfer initiated by APB bridge act as a requester. So see, whatever the transfer initiated by your APB bridge is act as a requester, and the who is fulfilling that transfer or and who is completing that transfer is known as a completer. Okay, so the master who are initiating the request is known as requester, and the slave who is completing that request are known as completer. Okay, yeah. Now see, this is the basic terminology which I already have discussed with you. Now see, this is the detailed diagram of how your APB protocol really communicate with your peripherals. So suppose let's see, here you have some CPU. Now we know that CPU start or CPU send the data in a higher rate. So suppose here your CPU sending a data to any peripheral in a higher rate, and in between the peripheral and your master we have attached one bridge. Now the role of this bridge or the responsibility of this bridge is to low down the frequency of your master. So suppose your master is sending a data in a higher rate, but here the peripheral which you have is accepting that transaction in a lower rate. So in that case, we need some sort of bridge that will low down the frequency. So here we are just passing this transactions from your master into this bridge. Now bridge is storing the transaction and passing it to your peripheral accordingly. So that bridge is nothing but your APB bridge. Okay, I hope it's clear. Okay, yeah. Now see, these are some of the common features which we have in your APB protocol. So it's a simple interface. So it also consumes a low power. It also operates with low bandwidth. Now synchronous operation. So what does it mean by the synchronous operation? So see here your all transaction, all your data transfer should be happened on a clock cycle. So here we are having a positive edge of clock cycle. So whatever operation you are performing, that should be going to happen on your poses of clock. Okay. Then non-pipelining. So what does it mean by the non-pipelining? So see here in APB protocol, you cannot pass your next data until the current transfer has been completed. Let me repeat my sentence. You cannot pass the next transaction or the next data until the current one is completed. Okay. So here your APB is supporting a non-pipelining behavior, whereas your AHB and AXI protocol are supporting a pipelining behavior that we will discuss in our further video. But you can keep this in mind. Here your APB protocol support a non-pipelining behavior. Then we have handshake mechanism. So what does it mean by the handshake mechanism? So see, whenever you are sending some transaction to your slave, so at that time you are waiting for the acknowledgement from the slave. If slave is ready, so slave will send the acknowledgement that I am ready, then you can complete your transfer. Otherwise your master have to wait until he is not getting an acknowledgement signal from your slave. Okay, so see in APB protocol we have one dedicated signal which is collecting the response from your slave. If slave is ready, so that signal is 1. If slave is not ready, so that signal should be 0. We will discuss those signal also. Okay. Then we have low complexity and low power consumption. Now see, since it's a simple two-phase protocol, there is only a two-phase, setup phase and access phase. So it reduces a control logic and processing overhead. Okay. Now I already have discussed this. There is no support of pipelining here in APB protocol and there is no support of any bus transfer. Now it is operating on a single clock operation. That's make it a low complex and also a low power consumption protocol. Okay. Yeah. Now see, these are some of the signals which we have in your APB protocol. These two signals are a global signal, P clock and P reset. So P clock is nothing but your clock signal on. See, now your all operation should synchronize with this clock signal, and here in APB protocol we are considering pauses as a valid clock edge. Okay. Now we have reset. Now this reset is an active low reset. So if you want to perform a reset operation, so in that case your reset signal should be low. Okay. Yeah. Now see, we have P address. Okay. So what does it mean by the P address? So suppose I have one memory where we have multiple address block. Now at which address block I want to pass the data, or from which address block I want to read the data. That thing we are deciding it from your P address. Okay. So the address which you are passing by your master, that address denotes that where you are going to write the data and from where you are going to read the data. Okay. Then we have P select signal. Now see why we are using this P select signal. So suppose you have multiple slave. Now at a time your master is only able to initiate the transfer or continue the transfer with only one slave. So at that time here this P select signal comes into the picture. So if you want to select your slave 1, so for slave 1 your P select signal should be high, and for the other slave your P select signal should be low. Okay. So see what really happening here. Here you have one master, and from this master we are passing the P address, and that P address is going into your decoder, and based on this address we are selecting the appropriate slave by passing the P select signal. Okay, I hope it is clear. Then we have P enable signal. Now see, in P select signal you are loading all those control and data information from your master. Okay, so in P select signal you are loading all the control and data information from your master. Now on the next clock edge you are asserting this P enable signal. Now when you are asserting your P enable signal, so you are moving from setup phase to access phase. Okay. Then we have this P ready signal. Now this P ready signal we are getting from your slave. So if P ready signal is 1, so that means my slave is ready to complete the transfer. And if it is low, so that means my master have to wait till we are not getting a P ready signal from your slave. Okay, so your data transfer should be completed only when all these three signals, that is your P select, then P enable and then P ready. If all these three signal is high, then and only then you can say that your data transfer is completed. If you are in setup or access phase and if P ready is low, so suppose if you are in access phase, okay, and if your P ready is low, so in that case your master have to wait till he is not getting the P ready from the slave. If he gets the P ready from your slave, then it can complete that transfer. Okay, yeah. Then we have PR data. Now see, PR data is nothing but your data bus. So in APB protocol, we have a dedicated data bus for your write operation and read operation. So if we want to write something to your slave, so in that case we are using this PW data bus, and if we want to read some data from your slave, in that case we are using this PR data bus. Okay. Then we have this P slave error. Now see, your P slave error is an optional signal that can be asserted by your slave in order to indicate that some error condition has been occurred during the APB transfer. Now then what are those scenarios where you can get this P slave error? Okay, so see, suppose if your memory is just a read only memory and if you are trying to write into that, so in that case you are going to get a P slave error. Now the another case is that if you are passing some invalid address from your master that is not present in your slave, so in that case also you are going to get your P slave error high, and this signal has been driven by your slave. Okay, then we have your operating state. Now see, this is, you can say, very important kind of thing. If you want to understand the APB protocol thoroughly, so this is very important part, so just focus on this. So see, whenever your P select and P enable is low, so in that case you are in idle phase. That means your master is in idle state. He is not involved in any of the transaction. Okay, now if I want to start some of the transfer, so in that case I have to move from your idle phase to setup phase just by asserting my P select signal 1. Okay, so if your P select signal is 1, so in that case you are in setup phase, but you also have to make sure that in the same scenarios your P enable signal should be low. Okay, let me repeat my sentence. If your P select signal is high and on the same cycle if your P enable signal is low, so you can say that you are in setup phase, and in setup phase you are loading all the control and data information. So in control information we have your P address, we have your P write. Now see, this P write signal indicate whether you want to perform a write operation or read operation. If this P write signal is high, that means you want to perform a write operation, and if it is low, that means you want to perform a read operation. Okay, I hope it is clear. Then in the next clock cycle you can just assert your P enable high, and see, this is the mandatory condition. If you are in setup phase, so in the next clock cycle you must have to go to your access phase. Okay, so in order to move from setup phase to access phase, you just have to assert your P enable signal high. Now in access phase you are monitoring your P ready signal. So if P ready signal is high, so in that case you can complete your transfer. But if it is low, here you can see, if it is low, so you can wait in this access phase only until you are not getting this P ready signal from your slave. And if you are getting this P ready signal from your slave, so either you can move to the setup phase and either you can move to your idle phase. Now in which scenarios you can move to a setup phase, or in which scenarios you can move to the idle phase. Now whenever you have left some of the transaction to be done, so in that case you can move to your setup phase. In that case you just have to deassert your P enable signal. Your P select signal should be high only. You just have to deassert your P enable signal. But if your all the data transfer has been completed, then you can move to your idle phase. In that case your both the signal, that is your P select and P enable signal, should be low. Okay, I hope it's clear. Now here you can see we are performing a write transfer with no wait state. Now no wait state means we are getting your P ready signal from your slave when your P select and P enable is high. So we are not in wait state. So see here from T0 to T1, here your P select signal is 0 and P enable signal is also 0. That means we are in idle phase. Okay. Now on the next clock cycle from T1 to T2, if you can observe this, so here you can see, here we have P select signal 1, but at the same time your P enable signal is low. So that means right now we are in setup phase, and once you move to the setup phase, so on the same clock edge only you have to load your address and data information. So here you can see I have uploaded the address as well as my data information. Here also you can observe my P write signal is 1, so that means I want to perform a write operation. Okay. Now on the next clock cycle, if you carefully observe that, so here you can see our P enable signal is high. Here you can see in previous cycle it's 0 and in next cycle it's 1. That means here we are in setup phase, and on the next clock cycle we are moving from setup phase to access phase. Okay. So by asserting P enable signal, we are moving from setup phase to access phase, and here you can see your P ready signal is high. That means your slave is ready to complete the transfer, so you can just send this data to your slave. Now on the next clock cycle, here you can see your data transfer is completed. Okay, so this is how your write transfer with no wait state look like. Okay, then we have your write transfer with wait state. Now here you can see this is very similar to the previous one. Only difference here is that when your P select and P enable signal both are high, but in the same case you can see here your P ready is low. In previous one, here you can see when your P select and P enable signal is high, so at the same time your P ready is also high. That means you are not in wait state, you can complete your transfer. But here in this, when your P select and P enable signal is high, but at that time your P ready is low, that means this data transfer should not be completed until your master is not getting a P ready signal from your slave. So here from T3 to T4, if you observe this, so here also your P ready signal is low, so that means we are in wait state. Now from T4 to T5, here you can see, here we have asserted this P ready signal, so that means now your slave is ready to complete the transfer. So at this cycle your master will send this PW data and all those information, and then you can say that now your transfer is completed. Okay. Now similarly like that we have read transfer with wait state and read transfer with no wait state. So if you are considering the read transfer, so there the only difference from your write transfer is that here your P write signal is low. In write transfer your P write signal is 1. Here you can see your P write signal is 1. So as a conclusion, if your P write signal is 1, so that means we want to perform a write operation. And if your P write signal is low, so that means we want to perform a read operation. I hope समझ आ रहा होगा सबको. आ रहा है ना? कमेंट करके बताना. Okay, I hope you guys are getting this point. Okay, if you face any difficulty, then you can also write in comments. I will definitely look into it. Okay, so this is all about your APB protocol. Now APB protocol, keeping it simple, efficient and low power. Now here you have just from setup phase to access phase and your job get done. So in order to complete a transfer, you just have to move from setup to access phase, and if you are getting your P ready high, so that means your complete transfer has been done. Okay. Then you have no burst, no drama. Now see, no burst. This is also advanced features which we have in AHB protocol and AXI protocol, but here you don't have to rely on burst or other kind of thing that make it reliable data transfer and also easy to model communication. Okay. Now let's jump into the RTL and we will see how you can implement your RTL. Now here you can see this is your RTL, and let me show you the verification plan whatever we have done. So here you can see we have considered a multiple class. We also have considered this something like package, which you have I think never seen this before. Then we have used this definition file. We will discuss all this in detail. So just watch this complete video. Now see, here this is your RTL. So here we are considering an APB slave in your RTL, and that we have to verify. So if your RTL is APB slave, then your test bench is going to behave like an APB master. Okay. So here you can see we have considered all those signal. We have P clock, that is your peripheral clock. Then we have P reset signal that works on active low. Then we have this P select signal. Now P select signal we are using in order to select the appropriate slave. Then we have P enable signal. Now your P enable signal we are using in order to move from setup phase to access phase. Then we have this P write signal. Now if your P write signal is low, so that means we want to perform a read operation, and if it is high, so that means we want to perform a write operation. Then we have this P address. So P address indicate that at which address we want to write or read the data. Okay. Then we have this PW data. So PW data is nothing but a data bus. By using this data bus, we are passing the data from your master to your slave. Then we have this PR data. So from this PR data, we are getting the data or we are reading the data from your slave. So by using this data bus PR data, we are reading data from your slave. Then we have this P ready signal. So it's an acknowledgement signal which we are getting from your slave. So if P ready is high, so that means your slave is ready to complete the transfer. And if it is low, so that means you have to wait until your slave is ready. Okay, then we have this P slave error. So if there is some error in your transaction, so you will get this signal high. That means there is error in your transfer. Okay. Now see, I have used this parameter n equal to 4. So why I have used this n equal to 4? So see, in order to introduce a wait state condition, I have used one parameter n equal to 4. That means I want to include a 4 wait state in my transfer. Okay. Then we have considered this memory, because since your APB protocol is behaving like a slave only, so that's why we have to consider one memory. Now this is your wait counter that we will see in logic. Now here we have just to keep your transaction active low, which indicate an active transaction. Now here you can see we are sampling at on the pauses of clock. Also we are considering a asynchronous reset. So from both of these, if anything get triggered, so your always block will get triggered and execute this following condition. Okay. Now if your reset is low, so that means you can just go to your idle phase. So in idle state, your P ready is low, P slave error is low, PR data is 0, and we are making just transaction active low. So see, right now you are in idle phase. So in that case, your transaction active is low. Then we have this wait counter. So we are going to add 4 cycle of delay or 4 cycle of wait state that we are going to monitor from this wait counter only. Okay, so by using this wait counter, we are going to count that number of wait. Okay, then we have this for loop. So in order to fill all the memory address block to 0, so for that reason we have used this for loop. So see, why we are just filling with 0? Because if you are in reset condition, you just want to fill all the address blocks with 0. Okay. So whenever you have reset condition, so in that case you just want to put 0 to your all address block. Okay. Then we have this P slave error. Now see here, whenever your P select and P enable is high and transaction active is low, that we have done in here in reset. So if it is low, so you have to just wait inside this wait state. Okay, so your slave is not ready to complete the transfer. Now see here we are just making transaction active 1. That means that now we can start transaction, but here your wait counter is 0 and we have to wait until your wait counter will reach to the value that is 4. Okay, so see here what we are doing, we are comparing it if transaction active. Now see here, if your transaction active is high, that means now your wait counter should check this condition. Now your n is 4, so 4 minus 1 3. Now your wait counter value is 0. So 0 less than 3, the condition is satisfied. Then you are incrementing the counter. So it will goes up to 3, and after 3, that means 0 to 3, that is you are counting a total 4 pulse, and after 4 pulse this condition will get false and you are entering into this else condition. And in else condition you are just passing this ready 1. That means now your slave is ready to complete the transfer. And if you are performing a write operation, so in that case you are just writing some data inside this memory. And if you are performing a read transaction, so in that case you are reading some data from your memory. Okay, now here you can see we are using this P slave error. So that means here these two address we are considered as invalid address. So if our master is passing these two address, so that address is not available in our slave. So our slave will give a P slave error as high. That means there is some invalid address we try to access. Okay. So that indicate that your master is trying to access some invalid address. Okay. I hope it is clear. Now let me repeat once again all those things. So see, here we have just considered always at the rate process of clock. Okay, so this always block is going to get triggered only when your clock is high or either your reset is low. Now if you are considering a reset condition, so in that case we are just filling all the memory block with 0 value, and also we are just keeping all the signal as 0. And now here we are considering a 4 wait state. So in order to include or in order to introduce a wait state in your slave, we have considered this wait counter. Now your wait counter is incrementing over here. Here you can see, so it will goes from 0 to 3, and after 3 this statement will get false and you will enter into this else condition. Now in else condition, here you can see, here we are just performing a write or read operation. So if your P write signal is high, so that means you want to write some data. Now see, PW data is your data bus which we are using in your master in order to pass some data from your master. So you are writing the data in your memory, and if your P write signal is low, so that means we want to read some data from your memory. So that thing we are doing it over here. Now see, here this one you can see, here if your address is 10 or 11, so at that address we are passing a P slave error 1. That means you are not allowed to use this address, and if your master is trying to access this address, so master will get a P slave error from your slave. Okay, so I hope the RTL part is clear. Now let's jump to the verification part. Okay, so see, in verification we have your test bench. So I hope it is visible. Yeah. Okay, so in verification environment we have your test bench. So in module TB top we have just included your all the macros which we have in your UVM, that is TIG UVM macros. Now see, the next thing here you can observe, we have included this package. So what's the intention of using this package? So see, whenever you are using your UVM architecture, so some of the class is repeatedly you have to use in some other class. So in order to include it manually, so here in package file I have included all those class in a sequence manner, so that I don't have to write it again and again in multiple class. See, if I am not doing it so what I have to do, here you can see I am using this APB transaction. So if I just want to use this APB transaction handle, so I have to call this APB transaction class, as well as in your driver I am using this APB trans. So if I want to use it over here, so I have to include this APB trans class. That I don't want to do it. So in order to avoid this, we are just included one package file where we are writing all those packages. Okay, now the next thing, here you can see we have generated our clock, and we are connecting your clock with your interface. Then we are connecting all the signals of RTL with your test bench. Okay, now here see, we have used this config DB. Now whenever I just want to deal with an interface in your class, so there I need some virtual interface, because see, in real time your interface is a static entity, so that I cannot access in your class, because your class is a dynamic entity. So in order to do it, so we have to use a virtual interface. Okay, so here we are passing a virtual interface. So here you can see, here I'm setting this config DB, and from where I want to receive the data, so there I can use this get method. Okay, so from where you are passing the data, so there you can use the set method, and from where you are receiving the data, you can just implement the get method. Then in order to run test, I'm just use this run test, and I'm passing the name of your test class, that is APB test, and this line and this dump file I have included in order to check the waveform. Okay, I hope it is clear. Then we have this interface class. So in interface class I have included all those signals which was there with your APB protocol. I already have discussed in detail of all those signals individually. Okay, then we have this clocking block. So I don't want any kind of skew and time delay in my code, so that's why I have included this clocking block. Now here you can see all the signals which you are driving from your driver, so that signals is considered as an output port. So the direction of that signal is considered as an output, and the signals which you are getting into the driver, so that is considered as an input. So see, here we are generating your reset, we are generating your P select, P enable, P write, P address, and PW. PW data. So all this transaction has been passed by your master. So that is considered as an output. This transfer we are getting from your slave into your driver. So that thing we are considered as an input. Similarly like that in monitor. Now in monitor we are going to sample all the signals. So all the signal are treated as an input in your monitor class. Okay. I hope it's clear. Now see, here we have used this define file. Now why I have to include this define file? So suppose here I want to pass, here I want to just allocate the width of this P address and PW data. So one thing I can do it in manual way like 7 down 0, and one thing is that I can just include this define file. So if I want to make some changes, so that I can directly change it from here only. So I don't have to check all this file in order to make any changes. So suppose in future I just want it to make from 8 to 16. So if I am just changing it over here, and that change should be reflected in your all the respective classes. Okay, now here you can see we have considered two constructor, one component constructor and the another is object constructor. So if you are developing some UVM architecture, so there it is compulsory in all the class you have to include the constructor, either it's your component constructor and object constructor. So instead of writing this 3 line again and again in your whole class, I have just included this constructor, and whenever I want to use this, I just call this macros. Okay, so in order to use this constructor, I just have to pass this macro. So that is just reducing my number of lines in my code. So that's the best practice that you can also follow while writing any test bench. Then we have this trans class. Now in trans class, we are mentioning all the signals and we are declaring the signal by using keyword rand in order to randomize the transaction. So here you can see I'm randomizing my reset, I'm randomizing my P write signal, I'm randomizing my P address signal, I'm randomizing my PW data signal, but I'm not randomizing my PR data signal, because see, PR data signal we don't have to generate the signals which the transaction which we have to generate, that signals we are randomizing it over here. The PR data we are going to get from your slave, so that you already have passed to your slave and you are reading from that slave. So that should not be a randomized signal. So that's why here your P ready, PR data and P slave error is not a random signal. Okay. Then I have used this field macro. So in order to print all those value associated with the signals, I have used this field macros. Now I have just considered a address. So if your address is 0 to 9, so that's a valid address range that we have in your APB. But here, if you are trying to access this 10 or 11, so here this RTL should throw an error or P slave error. So that's an invalid address range. That also we are going to check whether we are getting a invalid address or P slave error high or not. Then we have just restricted our data from 0 to 100 only. Now see, we have considered multiple test cases. So this is your right test cases. Now see, here I am just including my valid address range by passing the constraint mode 1, and I am just avoiding this another constraint that we have written, that invalid address range constraint. So in order to ignore that, we have to just write the constraint mode 0, so that disable that particular constraint. So if you are using it, so this will disable your particular constraint. So I just want to generate some valid address only. So that's why I have just included this constraint by disabling this constraint. Okay. Then here I have passed this PWrite equal to 1. So that means at each time or at each transaction, I just want to perform a write operation from these test cases. Now similarly like that in your read sequence as well, the only difference is that here your P write signal is 0. Because we already have learned, in order to perform a read operation, your P write signal must be low. Okay. Then we have back to back. So in that case, I am not giving P write 1 or 0. So that means your P write should completely a random signal. So your master will generate some signal, and based on that your operation will get performed. Then we are also considering here some negative case. So negative case means here I am passing an invalid address. So that means I am passing an invalid address in order to check my slave error signal is working correctly or not. Okay. So this is how you can develop your test bench as well. Here my address range, valid address range is 0 and invalid address range is 1. So from here we are going to pass 10 or 11 as an address. Okay. Then we have your driver. So in driver code, here you can see we have used this tick UVM component utils in order to register this particular class in your factory. Then we have used this constructor. Now see, we already have declared this constructor in your global definition, so we just have to use this field macro. Then we have considered this transaction. So your APB transaction TX is your transaction handle. Then we have interface handle. Now I already have discussed that if you are using your interface in your class, so you have to use a virtual interface instead of using the actual interface, because your actual interface is a static entity and you cannot directly use the static entity in your dynamic class. So in order to use that, you have to use the virtual interface. So this virtual interface is pointing to your actual interface only. Okay. Then we have build phase. So in build phase, we are just getting the config DB which we have sent from your TB top. So from TB top we have set those config DB, and here in your driver we are getting this virtual interface. Okay. Then we have run phase. So in run phase we are first creating your transaction handle. Then we are calling this get next item. Now see, sequence item port is an inbuilt port which UVM offers to us. So it's an inbuilt port, so we don't have to declare it explicitly. Now get next item. So this method tells your sequencer that driver is looking for some data. So we are not directly collecting the sequence from your sequence. Instead of that, we are passing a request to your sequencer, and if some transaction is available in your sequencer, so your driver will collect from it and then pass it to your DUT. But if there is not any transaction is there in your sequencer, so in that case your driver have to wait until the sequencer does not have any transaction. Okay. Then once you are getting the transaction, then you can send to it DUT, and then we are calling this item done. Now see, we are calling this send to DUT. So that means we want to pass those transactions, whatever we are getting it from your sequencer, to your DUT. Now in DUT, here I have added one cycle of delay. Now I am checking that if reset is low, so that means we are passing all the signal 0, and if it is high, so I am just passing here, you can see P select 1. That means I am moving from idle phase to setup phase. Initially your P select and P enable signal is low, but once your pauses will arise, then in that case we are just setting your P select 1. That means we are moving from idle phase to setup phase. Now here you can observe this, your P enable is low, because in setup phase your P select signal should be high, but your P enable signal must be low. And at the same time only, here you can see we have load all the control and data information. So P address, P write, all these are the control information, and PW data is your data information. Now on the next clock cycle, here you can see this is your next clock cycle. This is your first clock cycle, and this is your next clock cycle. So on the next clock cycle, we are just asserting your P enable high. That means now we are moving it from your setup phase to access phase. Now we are waiting for your P ready. Now if your P ready is high, so that means we can complete your transfer, and if P ready is low, so we have to wait it over here. Now if your P ready is high, then we are checking that if P write is low, so we can sample the PR data, and if it is high, then already we have said that PW data. So see here, if your P write is low, so that means we are sampling the data from your slave, and if your P write is high, that means we already have loaded this PW data, so we can say that your data transfer is completed. Okay. So this is how your driver codes look like. Then we have sequencer. So in sequencer we have just used this TQVM component utils in order to register this sequencer class in your factory. Then we have used this component constructor, which we already have defined in your global definition. Then also I have considered one reset sequence as well, where I am just keeping my reset low. That means in order to check the reset operation. Then we have your monitor class. Now in monitor class, now see here in monitor class we are sampling your signal. See here we have considered this field macro in order to register this this particular class in your factory. Then we have just considered this transaction handle and virtual interface. Now here we have considered one analysis port. Now your monitor job is to just sample all the signal from your DUT and pass it to your either reference model, scoreboard, coverage model. Okay, so your monitor has to broadcast the message. So whenever we want to broadcast the message, so at that time we have to use the analysis port. This is the syntax for your analysis port. Now we have here used the build phase in order to get the interface handle, because here also we are going to take help from your interface in order to collect data from your interface. Okay, so we have the data with your interface and we have to collect it. So in order to collect it, we have used this virtual interface handle. Now we are just allocating memory to this AP mon handle. Now here you can see in run phase, we are waiting for all those three signals should be high. Only in that case we are sampling those data, and it is also correct now. See, if you are continuously sampling it, so this will not make any sense. You can say that your data transfer is completed only when your all these three signal is high. So that's why we are checking all these three signal. If all these three signal is high, that means your data is sampled, and once it is sampled, we are just collecting your P address and P write from your interface and converting it from a pin level activity to your transaction level activity. Then we are checking that if P write is high, that means we want to pass a PW data, and if P write is low, so that means we want to pass a PR data. And after just converting all this pin level activity to a transaction level activity, that transaction we are sending it to your another class by using this write method. Okay, so whenever you are using your analysis port, so there we have write method in order to broadcast the message. Now here we have agent. So in agent we are just building all those three classes, your APB sequencer, monitor and driver. Okay, then we are establishing a connection between your driver and sequencer. Now see, what's the need of establishing this connection? So from your driver you have passed some from your driver you have initiated the request, and your sequencer is fulfilling that request. So we have to also connect that particular class. So that we are doing it in your agent. Then we have your scoreboard. So here you can see we have APB scoreboard, which we have extended from your UVM scoreboard. Then we have considered this field macro in order to register this class in your factory. Then we have considered one expected transaction handle as well. Now here you can see we are using this implement port. So here it's your UVM analysis implement. Okay. So here you can see this. Here we have UVM analysis implement. So whenever you are receiving the data, so you can use implement port, or from where you are sending the data, so there you have to use the port. Okay. Now here I am considering one memory. So in this memory, I'm gonna to store your PW data with the respective address. Okay, that we are going to see. Then here you can see we are calling this write method. So whenever you are calling this write method, so that means you get the transaction from where you have sent. So we have sent it from your monitor. So in order to get it, we have just implement this write method. Now see here I am just building my expected transaction handle. Now what I am doing it, now I'm just checking it. If P write is high, so that means we are performing a write operation. So I'm storing this PW data in your memory, which you have modeled it in your scoreboard. So see, this memory you have modeled it over here only. So I'm passing this PW data with that P address inside this memory. Okay. Now if your P write is low, so if your P write is low, so in that case, first of all, we are checking that this particular address exists or not. If this address not exist, so how you can able to read the data? So for that reason, we are checking that particular address exists or not. So if address exists, so that means we have to check your PR data with your memory. So see, here you already have stored some data inside your memory. So that data we are comparing it with your PR data. If both are same, so in that case you can say that your test case is pass, otherwise it failed. Okay. Then we have your environment class. So in environment class we are just building your scoreboard and agent, and also we are just establishing a connection between your agent and scoreboard, because see, we have passed the transactions from your monitor to your scoreboard. So that connection we are establishing over here. Here you can see we have called those agent.monitor, and inside this monitor we have AP mon handle, and inside scoreboard we have AP SCB handle, that we are connecting it over here in your UVM environment. Then finally we have your APB test, which we have extended from your UVM test. Then here we have used this tick UVM component utils in order to register this particular class in your factory. Now I'm just building this environment handle. Now see, I have just considered this two handle or two sequence, write sequence and read sequence. and then I have used this raise and drop objection, and I am just starting this sequence. Now in order to start this sequence, you have to just use this start method, and here your sequence handle, and here you have to derive, and here you have to synchronize it with the respective sequencer. Okay, so you have to connect this sequence with their respective sequencer. So that is that only we are doing it over here. Now let's run this code. So yeah, so see, let me just give you one golden point. If you want to become a good verification engineer, so in that case you don't have to check your waveform. Instead of that, you can check your log file. So why we have to check your log file? So see, if you going to check inside your waveform, either you are getting a correct output or not, so that will take your so much time, you also get confused sometime. So instead of that, you can just use this log manual in order to check whether all your test case is passed or not. So here you can see, here this all those test case is passed. Here you can see read pass, here you can see read pass. Now this address does not exist, so that means here it is showing address 3 does not exist. Okay, so here we have verified our APB protocol. Now in the next video, we are going to cover a APB VIP with a multiple agent. So if you have any doubt from this video, so you can either write it in comment, and you can also mail me with your doubts. I will ready to help you out. Okay, if you want any mock interview from our side, so you can just mail me. I will definitely take your mock interview and give you a honest and valuable feedback that will help you in your future interview. So thank you.